Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 3.1, day 1, entitled Quadratic Functions and Models. And today we're going to talk about graphing quadratic functions and then putting them in standard form. And we'll also talk about finding the maximum and minimum values of a quadratic function. Now, we have to remember that polynomial functions can be any degree of the variable. So even if you have y equals 2x, that x has a degree on it. The degree is 1. But now we're going to get into more complicated functions where we are seeing higher and higher degrees. So today we're going to focus on stuff that has a degree 2. Okay? So what this form means here is that you have your function, and these terms out front, this a sub n, that just stands for some constant, some number. And then you have a term that's less than that, or the next term, I guess I should say. And you keep going all the way until you have your very last term, or your constant. And then your x's have their degree on them. And as you go through, we're going to have them in descending order. So you're going to have your degree, -1, etc., until you get all the way down to no degree and just your constant term. So if we have something that has a degree of 0, that would just be like y equals 5. With no variable, so there's no degree on the variable. We could have something that has a first degree, like 2x plus 5. Okay, something with a second degree would have y equals 2x squared plus x plus 5. Okay, so again, you just have these terms, these constant terms out front. I have a 2, I have a 1, I have a 5. That's what the a sub n's are. And then your x's go in descending order. So here I have a power of 2, then I have a power of 1, then I have x to the 0 power. Okay, so this slide is just reminding you of those concepts. But what we're really going to focus on today is when we have a degree of 2. So these are all going to be quadratic functions. And they follow this standard form here, this ax squared plus bx plus c. Okay? Now your book calls that quadratic form. You know that in the past as being standard form. Okay? That's what we referred to that as in the past when you were in Algebra 2. That was called standard form, where you had the whole polynomial just written out with each term. Now what we're going to do today is we're going to convert that into vertex form. And your book calls that this, the standard form. And we're going to call this vertex form. Or that's what you did call it in the past in Algebra 2. And the nice thing about this form is that it tells you the vertex. Okay, you're going to have your a out front, and you're going to have x minus h squared plus k. Now the k is going to be your constant, or your intercept, your y-intercept. If you take h and k and put them together, that's going to be your vertex of your parabola. So that's why they call this vertex form, because it's in a form where you can pull that vertex right out of the equation. So this form is a little more user-friendly because you can pull some information right out of the form. You can take out the vertex, you can take out the y-intercept, and that can help you make your table of values to graph the function. Now, how we get an equation from the standard form into the vertex form is we complete the square. So this equation here in example 1, or this function, is f of x equals 2x squared minus 12x plus 23. So right now this is written in what you know as traditional standard form. Okay? And we're going to put it in vertex form. Okay? So to do that, we're going to complete the square. That's what we have to do. Now the thing is, we only complete the square with the first two terms, because those are our terms that have variables in them. Those are the two parts of our three parts of the trinomial that we need. So we need to take this x squared and this x and change it into a trinomial that's going to be factorable. That's how we get that x minus h squared into our vertex form. So what we're going to do first is we're going to just look at those first two terms, and I'm going to take out any numerical GCF. So I'm going to take a 2 out of those first two terms. So that leaves me with x squared minus 6x. And then I'm going to leave the 23, and I'm going to leave a little bit of space in here too, because this is where I'm going to put my third term so that I'm changing this binomial into a trinomial. So now we complete the square with this 6 here, this middle term. So just like we've done before, you take half of 6, which is 3, and you square it, which is 9. So that's going to be my value that I'm going to add there. Okay, so now I've completed the square. Now I've taken these two binomials and converted into a trinomial, so that way I can factor it. Now here's the trick. Remember, I'm not just adding 9. I'm adding 9 times 2. And this is all on one side of the equation. I'm still working on the right side of the equation. I haven't done anything to the left side of the equation where the f of x is. So I still have this plus 23 here, but I just added 18 to this right side of the equation. So I made this side 18 units bigger. So that means I have to keep it balanced. I have to undo that. Now what we've done in the past is if you add 18 to the right side, you add 18 to the left side. And you could still think of it that way, but you want to keep the f of x by itself, so then you're going to have to subtract the 18 over. Okay? So whatever you do to complete the square, you have to undo after your constant term. So now our last step then is to factor. Now remember, the trick is I'm always going to use a value that's half of that middle term. So if I was to factor this, you could think of it this way if you want. You can write your two sets of parentheses. And the factors of 9 that get you to 6 are 3 and 3. And to get them to add up to a negative 6 and multiply to a positive 9, you need them both to be negative. Now I'm going to rewrite this. So we'll have 2 times x minus 3 squared. So the stuff in the parentheses should match because it's going to be a perfect square trinomial. So you're always going to be able to write it as something squared. And then I want to combine my like terms there at the end, plus 5. So there is my vertex form. Now right away, from this form, I can tell that my vertex is going to be 3, 5. Now the vertex is always the opposite of the number that's inside the parentheses there, because I'm taking the value for h. And minus stays in the equation, in the formula for the vertex form. So I just want that number. I just want the 3. So I'm going to take the 3 and then 5. So in the equation, those are the values for hk. They don't use xy because there's an x and a y in the equation. You can think of the f of x like a y, and there's an x here. So we don't think of this ordered pair as x and y. It is, when we graph it, we'll still go over 3 and up 5, but for the sake of the formula that we had, those are the variables h and k that are represented by these numbers. Okay, so that's my vertex. And the other piece of information I know is this plus 5 at the end. That's my y-intercept. Okay? But if we're dealing with our y-intercept, we really want to think back to our original equation. Okay? So I'll come back to that in a moment because we're done with part A, but we're going to move on to part B now where they want us to graph the function. Okay? So to graph it, I'm going to make a table of values. I have x and f of x. And you can go to your graphing calculator and you can type in this function and get a table of values. But it's important to put it in that vertex form first because that vertex form tells you where your vertex is. And that's where you want to start your table of values. And by start, I mean put it in the middle. Because this is going to be a parabola when we graph it. So I want that vertex in the middle, and then I want to pick 2 values above that and 2 values below that in my x, y table. So I'm going to pick 1, 2, and then 4, 5. Okay, so that way you know where to look in your table of values on your graphing calculator. And you could, if you didn't have your graphing calculator, you could still substitute in 1 and square it and times it by 2. 12 times 1 is 12, so take that minus 12 plus 23, and you'll get 13. Or just put the equation into your graphing calculator and let the graphing calculator do the computations for you, and you just put the values in off the table. Now remember, it's a parabola, so you're going to see this repeating pattern in your y column. And again, this is our vertex here, the 3, 5, that's our vertex. Okay, so if I'm going to graph this, let me scooch down a little bit. Okay, so I've got 1, 13. I don't think I have 13 lines here. 7, 8, 9, 10, 11, 12, 13. Oh, look at that, I do. Okay, so 1, 13, 2, 1, 2, 3, 4, 5, 6, 7. And then 3, 1, 2, 3, 4, 5. All right, so there's our parabola. So putting it in vertex form helps us find our vertex. It helps us know where to focus in on our table of values. Helps us find 5 nice points to graph our parabola. I always say you need at least 5 points to graph your parabola. Notice that this leading coefficient was positive, so we know it's going to open up, which it does. Let's double check. And before we just walk away from it now that we have the graph done, there's a couple other components that you need to make sure that you are paying attention to, because these you're going to see on quizzes and tests. I'm going to ask you to find your domain of the function. Now this is a parabola. The x values, we have no restrictions on the x values that we can plug into this equation. This parabola, I know it looks like it's going up, but it's really going to go up and out forever and ever and ever to the left and to the right. So we're eventually going to cover all of the x values on our number line. So we have all real values for our domain. Now our range is limited a little bit because our parabola only comes down to 5, and all the other values are greater than that. Our parabola never goes below 5 on the y-axis. So our range is going to be all the y values that are greater than or equal to 5. I know it's 5 because 5 is right there. That's my lowest value. The other two concepts you want to make sure that you're paying attention to are your y-intercept and your x-intercept. Now remember, to find your y-intercept, you can plug 0 in for x into the original equation. So if I do that, I'm going to have 2 times 0 squared is 0, minus 12 times 0, plus 23. So I'm going to have 0 minus 0 plus 23. So my y-intercept is going to be 0, 23. And that makes sense. If I kept going and going and going, or if I plug 0 into this function just like I did, I get 23 out. So that means if I plug 6 into this function, I'll also get 23 get 23 out due to our properties of symmetry. Okay, so this parabola is going to start growing really, really quickly. And then of course we want to make note of what our x-intercepts are. Remember, the x-intercept is where the parabola crosses the x-axis. Our parabola never touches the x-axis, so we don't have any for this particular parabola. But those are 4 concepts that I want you to take a moment and jot down and think through as you're doing these homework problems, because that's important information that we're going to need to review all year for all types of graphs. Okay. Now, coming up next, we're going to talk about our minimum value and our maximum values of our graphs. And notice here that since our parabola opens up, it has a low point. The vertex is actually the lowest point. So this graph would have a minimum value. If our parabola opened down, it would have a high point, so it would have a maximum value. So there's the pretty book graph of what we just did. And notice here you can clearly see the y-intercept is at 23. Okay. So now when we start talking about our minimum and maximum values, basically your minimum and your maximum value of your parabola is the y value of your vertex. Like I just said, the parabola we graphed opens up, so it has a minimum value at the vertex. If the parabola opens down, it's going to have a maximum value at the vertex. Okay? And that actual value, it says right here, if your parabola is opening up, then the minimum value is going to be k. So you're going to put in the h value, which is your x value, and you're going to get k out. So in your ordered pair, hk, k is going to be your minimum value. And here, if your parabola is opening down, where a is less than 0, the maximum value is going to be k. So again, you put in h, and you get k out. And again, that h and k are coming from this vertex form. Okay, so on our previous example, our minimum value would have been 5. Okay, so let's take a look at 2 more examples here. So we're going to do what we did before. We're going to practice putting the function into standard form. We're going to graph it, and then we're going to find the minimum and maximum value. So here we have a function f of x equals 5x squared minus 30x plus 49. So I'm just going to focus on those first 2 terms when I'm completing the square. And again, remember this standard form, this is what we call the vertex form. So I'm going to take the 5 out as a numerical GCF. Basically, you're taking out whatever term is your lead coefficient, because we want that x squared to be by itself so that we can factor. And then I still have my plus 49. Now it's just coincidence that our 2 examples so far have had 6's for the middle term. That's not always going to happen. But half of 6 is 3, 3 squared is 9, so then I'll have x squared minus 6x plus 9. Now I added 9 here, but I'm multiplying it by 5, so I'm really adding a 45. So I want to undo that and subtract 45. That way the whole right side of the equation stays balanced. Then I'm going to factor, and this is always going to be a perfect square trinomial. So the factors of 9 that get me to 6 are going to be 3 and 3, and I would need it to be a minus 3 squared, and plus 4. So there's my vertex form or standard form of the function. So again, from this, I can tell that my vertex is going to be 3, 4. Remember, it's always opposite of whatever's inside the parentheses here with the x. It's whatever comes after the subtraction. So if you view this as a negative 3, then you put a positive 3, or just think of it as whatever comes after that subtraction sign. So now I'm going to go to my graphing calculator. I'm going to type this function in so I can get my table of values. But I'm going to start my table of values at 3, 4. That's going to be my middle value. So 3, 4 is my vertex, so that's going to go in the middle. And I'm going to pick 2 values above it and 2 values below it. Again, it's just coincidence that my vertexes or my vertices for the last 2 examples have had 3's in them. Just coincidence. Okay. Again, if you don't have a graphing calculator, you can still do this by hand. You have to take 1 and substitute it in to the original function. Take 2 and substitute it in, get a value, etc. So when I plug in 1, I'm going to get 24. 2 is going to be 9, and then it repeats. Now, those values of 24 are going to be way too big to fit on our graph, but I'll graph the other ones. At least the values of 24 will give us some sort of direction, so we know which way the parabola is going to be going and how fast it's going to be growing, how wide or how narrow it's going to be. So let's see, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I left just enough room. And then 3, 4. Okay, so these are just 3 of the points in my table. So you can see this parabola is going to be really skinny. It's going to be really stretched out, really narrow. So I made my graph. Now, before I completely walk away from the graph and before I do my minimum and maximum value, I'm going to talk about my domain, which again is going to be all real numbers. My range. Here my graph doesn't go below 4 on the y-axis. So I'm going to have y is greater than or equal to 4 for my range. For my y-intercept, I want to plug in 0 for the function. Plug in 0 for x. So if I plug in a 0 there, I'll get 0. 0 there, I get 0. So I'm going to have 49. So my y-intercept would be 0, 49. And x-intercepts, look at my graph. My graph doesn't cross the x-axis at all, so I'm going to have none. And again, that's just coincidence that the last two parabolas have not had any x-intercepts. That won't always happen. Okay, now the last part we're adding on here is that minimum value. If you look at your graph, you can see that that vertex is a low point. It's a minimum on the graph. It's the minimum point or the lowest point. So the value then is going to be your k value, hk, so that's going to be 4. So my minimum value, I'll write it down here, is going to be 4. Okay, so we're going to take a look at this one more time. There's a nice, pretty book graph that shows the y-intercept at 49. Now this time, we're going to get some x-intercepts. And this time, when we factor to complete the square, we're going to get some messy fractions. Do not be afraid of the fractions. It's okay. You can still do these problems and get fractions in your standard form or your vertex form. You can have fractions in your vertex, and you can still pick nice numbers to graph. You can pick whole numbers to put on your actual graph. So this problem is going to be a little more challenging just because it's going to be a little messier with the fractions. But we're still going to start off the same way. Remember again, this standard form, think of it like vertex form. Okay, we're going to complete the square to do that. I'm going to take a look at these first two terms. I'm basically taking out my a value here, which is a -1. So I'm going to take the -1 out as a numerical GCF. So that means I change my signs. I still leave the +2. Then I'm going to take half of 1, which is a half, square it, which is a fourth. Now, I like to write this as fractions. If you want to write it as decimals, you can. Now, this fourth that I added here in the parentheses is really getting multiplied by a -1. So I just subtracted 1/4. So I'm going to have to do the opposite here, and I'm going to have to add a fourth on after the 2. So now my vertex form will be -1 times. Now, again, this is a perfect square trinomial. So we need the factors of 1/4 that are going to add up to 1. So that's going to be 1/2. Remember, it's always half of this second term's coefficient. So there's a 1 here. So half of 1 is a half. And it's going to have to be a minus. We've got a minus here. And we want the factors to add up to a -1 but multiply to a +1/4. So we need -1/2 and -1/2. Now, this 2 1/4, if you want to write it 2 1/4, you can. I'm going to write it as an improper fraction. And that's probably the preferred way. Some people might write it 2.25 because they like decimals. I prefer it to be an improper fraction. You need to get a little more comfortable with your fractions, proper and improper. Because as we get more and more advanced with our graphing, it's going to be more convenient to leave everything in fractional terms instead of decimals. Okay? So again, we know from this work that our vertex is going to be, yuck, 1/2, 9/4. Messy. Messy because it's fractions, but still completely graphable. You know where 1/2 is, and you know where 2 1/4 is on a graph. So you can plot that point. It's just a little more of an estimation since it's not nice, neat points on the graph grid. But now when we go to part B, they're going to want us to graph it and then find the maximum value. Because this time our lead coefficient was a negative, so we know our parabola is going to open down. So when it opens down, it's going to have a maximum. Okay, so I'm still going to make my table of values. I'm still going to put my vertex in the middle. So that's where I'm going to be starting my table, so to speak. Now, I would still go to your graphing calculator. I would still put in this function and then go to your table of values and get nice whole numbers to graph. A couple of numbers above and below 1/2. Let's see, 1/2 is between 0 and 1. And then you can have -1. You might need a few more. You might need -2. You might need 2 and 3. Sometimes when you have fractions for vertices, it means that you might need more values than just 5 to get the complete picture of the parabola. So use your judgment there to know how many values you need. But you should get -4, 0, and 2 for your values. Again, that pattern is going to repeat because it's a parabola. So when we graph this one, I'm going to make the axes a little bit higher because I know it's going to open down. So I'm going to start at -2, -4, -1, 0, 0, 2. That value's on the x-axis and this value's on the y-axis. And I've got 1/2 and then 2 1/4. So right about there, there's my vertex. And then 1, 2, and then 2, 0. Oh, that's on the x-axis again. I'm pointing that out because that's important information. We're graphing our x-intercept and our x-intercepts and our y-intercept. We have all those pieces of information in our table of values and in our graph. Okay, so the parabola opens down just like it should. And we're still going to find our domain, which is going to be all real numbers. Our range, this time, our graph does not go above that 9/4 value. That's my highest point on the parabola, 2 1/4. So my range is going to be everything less than that. Now my y-intercept, we see it in our table of values, and we see it on our graph. The graph crosses at 0, 2, so it crosses the y-axis. And we actually get our x-intercepts on our table of values and on our graph as well. So the x-intercepts are going to be right here, -1, 0, and 2, 0. Okay, so remember that. Remember for x-intercepts, you plug in 0 for y. So in your table of values, any ordered pair that has a y value of 0, that's an x-intercept. Now we still have to find our minimum value, but we already found it. We just basically have to write it down. Okay. Or I'm sorry, our maximum value. Oops. Our graph is opening up, so we have a maximum. So our maximum value, that's the highest point. The highest y value that we get out is 9/4. Okay. So these are the concepts that you want to make sure that you're putting down in your homework problems, even though it may or may not be asked for in the directions. Take a moment and push yourself to think of these 4 concepts. What's my domain, my range, my x-intercept, my y-intercept? It's going to help you do the problem better. It's going to help you understand it better. It's going to help you understand our graphing in the future better. It's going to tie all these concepts together for you. Okay. Now remember, if you don't find your x-intercepts in your table of values, you can still find them by plugging in 0 for y. And I'm going to do that little work on this page by the nice neat book graph of our parabola. Remember, to find your x-intercept, you can plug 0 in for y. So our equation was y equals, or f of x equals, so that's where the 0 is going to go, negative 2x squared plus x plus 2. Now, if I just asked you to solve that, you'd factor. Okay? We'd want to take out a negative 1. We'd want to divide everything by negative 1 because we can't factor if that's negative. So if we divide everything by a negative 1, we're going to change all our signs. 0 divided by negative 1 is still just 0. And now we can factor this. The factor is a 2. That'll get me to 1. That's going to be a 2 and a 1. And I need it to get me to a negative 1. So I need the 2 to be negative and the 1 to be positive. And we did this in chapter 1. You solved equations like this, and you set each little parenthesis equal to 0 and solved it. So there you go. There's one x-intercept. There's your other x-intercept. Okay? Those are the solutions. Those are the roots. That's where the graph crosses the x-axis at negative 1 and at 2. Okay, so again, these concepts are all connected. In pre-calculus and calculus, that's where all of this math really starts to come together and make some connections. So this is why we're stressing domain and range and x-intercepts and y-intercepts with these graphs. So the homework isn't super duper long, but definitely practice these problems. Help yourself to some graph paper. If you have questions, come on in and see me before school.